Optimal digestive health forms a fundamental cornerstone of overall physiological well-being, extending its influence far beyond the gastrointestinal tract to encompass immune function, metabolic regulation, and even neurological processes. This report synthesizes current scientific understanding regarding dietary and lifestyle interventions that profoundly impact digestive function. A diverse, whole food-based diet, rich in specific types of fiber, coupled with adequate hydration, plays a pivotal role in maintaining bowel regularity and fostering a robust gut microbiome. The deliberate inclusion of probiotic-rich, fermented foods, and prebiotic fibers actively cultivates a thriving microbial ecosystem, which in turn produces beneficial metabolites crucial for gut integrity and systemic health. Furthermore, essential vitamins and minerals provide indispensable micronutrient support for enzymatic processes and tissue maintenance throughout the digestive system. Beyond specific nutrients, this review underscores the critical importance of incorporating anti-inflammatory foods, particularly those abundant in omega-3 fatty acids, polyphenols, carotenoids, and potent compounds like curcumin and gingerols to mitigate gut inflammation. Equally vital is the identification and judicious avoidance of dietary elements and lifestyle factors known to compromise digestive health, including ultra-processed foods, excessive sugars and unhealthy fats, and chronic stressors like inadequate sleep and psychological strain. The report advocates for a holistic, personalized approach to nutrition, emphasizing mindful eating practices, gradual dietary adjustments, and professional guidance where complex digestive conditions are present. By integrating these evidence-based strategies, individuals can significantly enhance their digestive resilience and promote long-term health. The human digestive system represents a marvel of biological engineering, a complex and highly coordinated network of organs working in concert to transform ingested food into absorbable nutrients and eliminate waste. This intricate process commences in the mouth, where mechanical breakdown through chewing and initial enzymatic digestion by salivary amylase begin the preparatory stages for nutrient assimilation. The food then traverses the esophagus to the stomach, a muscular organ responsible for churning and further chemical breakdown. Here, hydrochloric acid and proteolytic enzymes, such as pepsin, initiate the significant digestion of proteins, converting them into smaller polypeptide chains. This gastric phase is crucial, though protein digestion in the stomach takes longer than carbohydrate digestion, but less time than fat digestion. Following the stomach, the partially digested food, now a semi-liquid mixture known as chyme, enters the small intestine. This segment of the digestive tract is the primary site for nutrient absorption, facilitated by an extensive surface area and the concerted action of various digestive enzymes. The pancreas, a vital accessory organ, acts as the enzyme powerhouse of digestion, secreting a comprehensive array of enzymes, including amylase for carbohydrates, lipase for fats, and proteases for proteins into the small intestine. These pancreatic enzymes are critical for breaking down macronutrients into their most basic absorbable units: simple sugars, fatty acids, and amino acids. The liver, another indispensable organ, produces bile, which is stored in the gallbladder and released into the small intestine to emulsify fats, a necessary step for their efficient digestion and absorption by Lipase. The coordinated release of these enzymes and bile, alongside the small intestine's own enzymes, for example, lactase, sucrose, ensures that food is efficiently broken down and nutrients are absorbed into the bloodstream. The seamless functioning of this system relies heavily on the harmonious interplay between its components. For instance, the optimal activity of pancreatic enzymes is dependent on the precise pH regulation achieved through bicarbonate ions from the pancreas and bile from the liver and gallbladder. A disruption in one part of this complex machinery, such as pancreatic insufficiency leading to inadequate enzyme production or liver disorders affecting bile secretion, can cascade into widespread digestive difficulties, impairing nutrient absorption and leading to symptoms like maldigestion and malnutrition. This emphasizes that digestive health is not merely a sum of its parts, but a dynamic, interconnected biological process where each component's efficiency impacts the whole. Beyond the macroscopic organs, the human gastrointestinal tract hosts a vast and complex ecosystem of microorganisms, collectively known as the gut microbiome. This community, predominantly comprising bacteria, but also including fungi, viruses, and archaea, is estimated to contain approximately 100 trillion microbial cells, with bacteroidetes and firmicutes being the most prevalent bacterial phyla in a healthy adult gut. The gut microbiome is not merely a passive inhabitant. It is a central regulator of human health, exerting profound influences on digestion, nutrient metabolism, and immune system development and function. The microbiome plays a crucial role in breaking down complex carbohydrates and fibers that human enzymes cannot digest, fermenting them into beneficial compounds such as short-chain fatty acids, SCFAs, these including butyrate, acetate, and propionate, are vital energy sources for colon cells, contributes to gut barrier integrity, and possess anti-inflammatory properties. Furthermore, the gut microbiome aids in the synthesis and absorption of certain vitamins, such as vitamin K, riboflavin, and folate, and assists in the breakdown and recycling of bile after digestion. The influence of the gut microbiome extends beyond direct digestive processes. It is intimately involved in training and modulating the host's immune system, helping it differentiate between beneficial commensal microbes and harmful pathogens. An imbalance or deficit of beneficial microbes, a state known as dysbiosis, is increasingly associated with a range of chronic gastrointestinal conditions, including irritable bowel syndrome, IBS, inflammatory bowel disease, IBD-like, ulcerative colitis, and Crohn's disease, and even chronic bacterial infections such as H. pylori and C. difficile. Emerging research also suggests a bidirectional communication pathway between the gut and the brain, known as the gut-brain axis, through which the gut microbiome can influence mood, mental acuity, pain tolerance, and fatigue. This highlights that the impact of dietary choices is not merely direct chemical interaction with human cells, but significantly how these choices shape and sustain the microbial communities within the gut. The health and diversity of this microbial ecosystem, in turn, dictates the production of beneficial compounds and the modulation of systemic physiological responses. Dietary choices are not merely a source of energy. They are a profound and continuous modulator of digestive function and overall health. The foods consumed directly provide the substrates that the digestive system processes, influencing everything from the efficiency of nutrient extraction to the composition of waste material. A diet rich in fiber, for instance, adds bulk to stool, promoting regular bowel movements and preventing constipation, while adequate hydration keeps stools soft and facilitates their passage. Beyond these immediate mechanical effects, diet fundamentally shapes the gut microbiome, which, as previously discussed, is a central player in digestive and systemic health. Dietary patterns rich in plant-based foods, such as vegetables, legumes, grains, nuts, and fish, have been shown to modulate the gut microbiota in ways that prevent intestinal inflammatory processes. This occurs through synergistic effects on the gut microbiome, where diverse plant fibers and other compounds foster the growth of beneficial bacteria, leading to the production of anti-inflammatory SCFAs. Conversely, diets high in processed foods, unhealthy fats, and refined sugars can disrupt this delicate microbial balance, promoting a pro-inflammatory environment and potentially compromising gut barrier integrity. The influence of diet extends even to the complex interplay between the gut and the brain. Given that the gut microbiome is a key mediator in the gut-brain axis, and dietary components directly influence the microbiome, food choices serve as a primary, accessible means of modulating this critical connection. For example, the mineral magnesium obtained through diet not only supports gut motility, but also influences the gut-brain axis by promoting beneficial gut bacteria and regulating neurotransmitters like serotonin, which impacts both gut movement and mood. This suggests that dietary interventions can be a complementary strategy for managing stress, mood disorders, and cognitive function by targeting the gut-brain connection. Therefore, dietary patterns are not just about physical comfort. They are a powerful tool for influencing the entire spectrum of digestive health and its far-reaching systemic implications. Dietary fiber, a type of carbohydrate derived from plants that the human digestive system cannot fully break down, is a cornerstone of optimal digestive health. Its importance extends beyond simply promoting bowel regularity. It plays a critical role in shaping the gut microbiome, influencing satiety, and contributing to overall systemic well-being, including reduced risks of heart disease and type 2 diabetes. Despite its myriad benefits, most adults in Western populations, including the UK and US, do not consume adequate amounts of fiber, falling short of the recommended daily intake of 25 to 38 grams. When increasing fiber intake, it is crucial to do so gradually, over several weeks, to allow the digestive system to adapt, thereby minimizing common side effects, such as intestinal gas, cramping, and bloating. Soluble fiber, as its name suggests, dissolves in water to form a viscous, gel-like substance, within the digestive tract. This unique property confers several significant benefits for digestive health. By forming a gel, soluble fiber slows down the digestive process, which can contribute to a prolonged feeling of fullness and assist in weight management by reducing overall calorie consumption. This slower transit also aids in the regulation of blood glucose levels and can help lower cholesterol, crucially for bowel function. Soluble fiber absorbs water, which helps to soften stool, making it easier to pass and preventing constipation. This water-absorbing capacity is particularly beneficial for individuals experiencing loose stools or diarrhea, as it can help to bulk up the stool by removing excess fluid, thereby promoting more consistent bowel movements. Thus, soluble fiber plays a versatile role in regulating bowel consistency, adapting to whether the stool is too hard or too loose. Adapted, there is adequate fluid intake. Excellent sources of soluble fiber include a variety of fruits, such as raspberries, 8.0 grams per cup, pears 5.5 grams per medium fruit, apples, with skin 4.5 grams per medium fruit, bananas, 3.0 grams per medium fruit, oranges, 3.0 grams per medium fruit, and strawberries, 3.0 grams per cup. Vegetables, like boiled green peas, 9.0 grams per cup. Boiled broccoli, 5.0 grams per cup. Boiled turnip greens, 5.0 grams per cup. And boiled Brussels sprouts, 4.5 grams per cup, are also rich sources. Grains such as oats, 4.0 grams per cup. Instant oatmeal and barley, 6.0 grams per cup. Cooked pearled barley are notable contributors. Legumes, including boiled split peas, 16.0 grams per cup. Boiled lentils, 15.5 grams per cup. And boiled black beans, 15.0 grams per cup, are exceptionally high in soluble fiber. In contrast to soluble fiber, insoluble fiber does not dissolve in water. Instead, it retains its structural integrity as it moves through the digestive system. Its primary function is to add bulk to the stool, acting like a broom in the colon to promote the efficient movement of waste material through the digestive tract. This bulking effect and acceleration of transit time are particularly effective in preventing and alleviating constipation, while generally beneficial for promoting regularity in healthy individuals. The rapid transit and abrasive nature of insoluble fiber can sometimes exacerbate symptoms in sensitive digestive systems. For individuals with irritable bowel syndrome, with constipation IBS-C, some research suggests that insoluble fiber may be less well tolerated than soluble fiber, potentially leading to increased gas, bloating, and cramping. Similarly, during some active flares of inflammatory bowel disease, IBD, or in the presence of intestinal strictures, narrowing of the intestine, fistulas, or recent surgery, a high intake of insoluble fiber is often advised against, as it can worsen symptoms like diarrhea, pain, and potentially cause blockages. In such cases, modifying the texture of fiber-rich foods through cooking, peeling, or blending can make them more tolerable, as this can alter the fiber's properties. sometimes making insoluble fiber behave more like soluble fiber in the intestines. Rich sources of insoluble fiber include whole wheat products, especially wheat bran, brown rice, 3.5 grams per cup cooked, quinoa, 5.0 grams per cup cooked, and other whole grains like buckwheat and millet. Many vegetables, particularly leafy greens such as kale and spinach, broccoli, 5.0 grams per cup boiled, Brussels sprouts, 4.5 grams per cup boiled, and potatoes with their skins, 4.0 grams per medium baked potato, are good sources. Fruits with edible skins and seeds, along with nuts, almonds, at 3.5 grams per ounce, pistachios at 3.0 grams per ounce, and seeds, sunflower kernels, at 3.0 grams per 1/4 cup, also contribute significantly to insoluble fiber intake. The critical understanding here is that while fiber is essential, the specific type and its preparation must be carefully considered and individualized, particularly for those with compromised gut health. Prebiotics are a specialized category of dietary fibers that are not digested by human enzymes, but are selectively fermented by beneficial microorganisms in the gut, thereby conferring a health benefit to the host. They essentially act as food for the good germs in the gut, promoting their growth and activity. A primary mechanism of prebiotic action is their fermentation by gut bacteria to produce short-chain fatty acids, SCFAs, including butyrate, acetate, and propionate. These SCFAs are crucial for maintaining the health of colon cells, influencing metabolic health, and mediating anti-inflammatory responses within the gut and systemically. Specific prebiotic compounds and their rich food sources include inulin and fruit, Ligasachus, FOS. These are abundant in chicory root where inulin can comprise up to 68% of its fiber. Dandelion greens, Jerusalem artichokes, garlic, onions, leeks, asparagus, and unripe green bananas. Inulin, for example, improves digestion and bowel function and aids in mineral absorption. FOS helps strengthen gut flora and fat breakdown. Beta-glucan, found in barley and oats. Beta-glucan is known to lower cholesterol and may help regulate blood sugar levels. Pectin, a soluble fiber with prebiotic benefits. Pectin is found in apples, berries, and avocados. It increases butyrate, an SCFA that nourishes beneficial gut bacteria. Resistant starch, present in legumes, unripe bananas, and cooked in cooled pasta or potatoes. Resistant starch also acts as a prebiotic. Other sources: flax seeds promote healthy gut bacteria and regularity. Cocoa, rich in polyphenols, supports the growth of beneficial gut bacteria. Wheat bran contains arabinoxolin, oligosaccharides, axos, that boosts bifidobacteria. Seaweed, a marine algae, contains polysaccharides that increase SCFA production. It is important to recognize that while prebiotics are generally beneficial, their effects can be nuanced, particularly in individuals with pre-existing gut conditions. For example, Some individuals with irritable bowel syndrome (IBS) may be sensitive to certain prebiotic fibers, such as inulin, fructan, FOS, or GOS, which can cause bloating or stomach upset. More critically, in inflammatory bowel disease (IBD), the role of prebiotics is complex. While fermentation of prebiotics by gut microbes typically reduces inflammation by releasing SEFAs, unfermented beta-fructans can paradoxically lead to an inflammatory response and gut barrier changes, especially when the gut environment is already inflamed or the microbial capacity to ferment fiber is reduced. This highlights that the therapeutic potential of prebiotics in IBD is highly dependent on the specific fiber type, the patient's immunological condition, and the fermentative capacity of their gut microbiota. Therefore, a personalized dietary approach is essential, and careful monitoring is advised when introducing prebiotics, particularly in individuals with active gut inflammation, to harness the full benefits of dietary fiber. Adults should aim for a daily intake of 25 to 38 grams, with approximately 6 to 8 grams coming from soluble fiber sources. Given that most populations typically consume only about half of this recommended amount, strategic integration into daily meals is essential. The introduction of fiber should always be gradual, increasing intake by only a few grams at a time over several weeks. This allows the gastrointestinal system and its microbial inhabitants to adapt, thereby minimizing common discomforts such as gas, cramping, and bloating. Concurrently, maintaining adequate fluid intake is paramount, as fiber absorbs water and requires sufficient hydration to function effectively in softening stool and preventing constipation. Without enough fluid, fiber can become counterproductive, potentially exacerbating constipation. A diverse array of fiber sources should be prioritized to ensure a broad spectrum of benefits. This includes whole grains, such as oats, for example, a warm bowl of oatmeal for breakfast, brown rice, whole wheat bread, quinoa, barley, and millet. Choosing whole grain versions of pasta and cereals is also beneficial. Fruits, crisp apples, juicy berries, pears, bananas, and oranges are excellent choices, providing both fiber and water. Vegetables, spinach, kale, and other leafy greens are rich in fiber and magnesium, which supports muscle contractions in the digestive tract. Other beneficial vegetables include broccoli, carrots, green peas, Brussels sprouts, and potatoes, especially with their skins closing legumes, lentils, and split peas, are exceptionally high in fiber and can be easily added to stews, curries, and salads. Nuts and seeds, chia seeds, almonds, and pistachios offer a convenient way to boost fiber intake. For individuals with sensitive digestive systems, such as those with IBS or during IBD flares, or with conditions like intestinal strictures, a more tailored approach to fiber is necessary. Focusing on soluble fiber sources and consuming fruits and vegetables that are thoroughly cooked, peeled, or blended can significantly improve tolerance. Pureed beans, white rice, instant oatmeal, and nut butters are often better tolerated initial choices. When symptoms subside, insoluble fiber can be gradually reintroduced. This emphasis on personalized and gradual dietary modification is crucial for maximizing the benefits of fiber while minimizing discomfort. Adequate hydration is an often underestimated, yet absolutely critical component of optimal digestive function. Water is not merely a thirst quencher. It is an indispensable medium for numerous physiological processes, including the entire cascade of digestion and nutrient absorption. Water plays several direct and indirect roles in facilitating smooth digestion. Firstly, it is essential for the initial breakdown of food, helping to create saliva in the mouth and forming a crucial component of stomach acid and other digestive fluids throughout the gastrointestinal tract. This liquefaction of food particles allows for more efficient enzymatic action and nutrient extraction. Secondly, and perhaps most critically, sufficient fluid intake is paramount for maintaining stool consistency and preventing constipation. Dietary fiber, while highly beneficial, acts like a sponge, absorbing water as it moves through the digestive system. Without adequate fluid, this fiber cannot fully hydrate, leading to dry, hard stools that are difficult to pass, thereby exacerbating constipation rather than alleviating it. The relationship between fiber and water is synergistic. One cannot function optimally without the other. This means that any dietary advice to increase fiber must always be accompanied by explicit recommendations for increased fluid intake to ensure the fiber can perform its intended role effectively. Furthermore, consuming water, particularly in the morning, can provide a powerful reset for the digestive system. A significant influx of fluid upon waking can stimulate peristalsis, the rhythmic, wave-like contractions of the intestines that propel food and waste through the digestive tract. This activation of peristalsis aids in stimulating regular bowel movements and can effectively alleviate constipation. Morning hydration may also dilute stomach acids, potentially reducing instances of acidity and heartburn, and primes the gut for more efficient absorption of nutrients from subsequent meals. To support digestive health, individuals should prioritize drinking plenty of fluids, with water being the optimal choice. A simple and practical strategy is to incorporate a glass of water with every meal. For those seeking to enhance morning digestive function, sipping approximately 1 liter of water over a period of 5 to 10 minutes upon waking is recommended, rather than rapidly consuming it to avoid discomfort such as bloating or a pukish sensation. Following this morning hydration with a 30 to 45 minute waiting period before breakfast allows for optimal absorption and gastrointestinal reset, enabling the water to perform its flush and prep functions. Conversely, certain beverages can negatively impact digestion and should be limited or avoided. Caffeinated drinks such as coffee, tea, and some fizzy drinks can boost acid production in the stomach, potentially leading to heartburn in some individuals. Fizzy drinks in general can cause bloating, which may also contribute to heartburn. Opting for non-fizzy, non-caffeinated alternatives like herbal teas, milk if tolerated, or plain water is advisable to reduce the likelihood of digestive problems. Fats are an essential macronutrient, vital for energy, hormone production, and the absorption of fat-soluble vitamins ADEK. However, that type of fat consumed significantly impacts digestive health, influencing gut integrity, microbial balance, and inflammatory processes. Omega-3 polyunsaturated fatty acids, PUFAs, patylake acid EPA, and docosahexaenoic acid DHA are renowned for their potent anti-inflammatory properties. These healthy fats play a crucial role in mitigating inflammation throughout the body, including within the gastrointestinal tract, making them particularly relevant for conditions involving chronic inflammation like inflammatory bowel disease, IBD. The anti-inflammatory effects of omega-3s south are mediated through sophisticated biochemical pathways. They serve as substrates for the production of anti-inflammatory eicosanoids, which are signaling molecules that help regulate the inflammatory response. More profoundly, omega-3 south are indispensable for the synthesis of specialized pro-resolving mediators, SPMs, such as resolvins, muresins, and protectins. These compounds are not merely anti-inflammatory. They actively facilitate their solution of inflammation, a critical process for healing and restoring tissue homeostasis. This means that omega-3 south contribute to turning off the inflammatory cascade, promoting a return to a non-inflamed state. Beyond this, omega-3 south can reduce oxidative stress, decrease the production of pro-inflammatory cytokines like TNF, alpha, and IL-1 beta, and may influence the progression of IBD, potentially alleviating IBD-related joint pain. Rich food sources of EPA and DHA are primarily fatty fish, including salmon 1,610 milligrams, DHA plus EPA per 75 grams serving. Anchovies 1,540 milligrams per 75 grams. Sardines 730 milligrams per 75 grams. Mackerel 900 milligrams per 75 grams. And trout 700 milligrams per 75 grams. Plant-based sources, such as flax seeds, 1,600 milligrams ALA per 75 grams, serving walnuts, 630 milligrams ALA per 60 milliliters. Canola oil, 1,320 milligrams ALA per 15 milliliters. And soybean oil, 940 milligrams ALA per 15 milliliters, provide alpha-linolenic acid, ALA, which the body can convert to EPA. And DHA, although this conversion is generally inefficient. Enriched eggs, milk, yogurt can also contribute smaller amounts of omega-3s for the general population. A minimum intake of 400 to 500 milligrams per day of combined DHA and EPA is advised. This can often be achieved by consuming 2 or more servings, 75 grams, or 2.5 ounces each of fatty fish per week. While the optimal amount for individuals with IBD is still under investigation, research indicates promising results for decreasing intestinal inflammation with adequate intake. This positions omega-3 south as vital dietary components, not just for general health, but as a proactive strategy for managing inflammatory processes within the gut. The quality and type of fats consumed exert a significant and differential impact on digestive health, while healthy fats, particularly unsaturated fats and omega-3 south, support beneficial physiological processes. Unhealthy fats can actively compromise gut function and promote inflammation. Unhealthy fats. Foods high in unhealthy fats, such as chips, burgers, and fried items, are inherently harder for the digestive system to break down. This increased digestive burden can lead to immediate discomforts like stomach pain, heartburn, bloating, and sluggish digestion. Beyond acute symptoms, these foods are often low in fiber, further slowing transit time. A diet characterized by a high intake of processed and ultra-processed foods, UPFs, which frequently contain unhealthy fats, refined sugars, and artificial additives, can profoundly disrupt the delicate balance of the gut microbiome. These dietary patterns promote a pro-inflammatory environment within the gut, reducing microbial diversity and increasing intestinal permeability, often referred to as leaky gut. This compromised barrier allows potentially harmful substances to translocate from the gut lumen into the bloodstream, triggering systemic inflammation. Furthermore, specific industrial processes used in UPF production, such as the Maillard reaction and hydrogenation, can create pro-oxidant and carcinogenic compounds. While emulsifiers used in these foods may prevent the proliferation of beneficial anti-inflammatory bacteria. High intake of saturated fats, prevalent in many UPFs and red meats, is also linked to increased inflammation and cardiovascular disease risk. Excessive consumption of unhealthy fats can also lead to more direct digestive problems. Unabsorbed fat can accumulate in the small intestines and colon, drawing water into the bowel and causing diarrhea. If chronic, this can result in malnutrition due to impaired nutrient absorption. Signs that the gastrointestinal tract is overloaded with fat include persistent bloating, gas, loose stools, and general fatigue, as the body expends significant energy attempting to break down the high fat load. Healthy fats. In contrast, prioritizing healthy fats supports digestive well-being. This involves opting for unsaturated oils like rapeseed, olive, or sunflower oil over saturated fats such as butter, lard, ghee, coconut oil, and palm oil. Choosing lean meats like turkey, fish, and chicken, and limiting red and processed meats is also beneficial, as lean meats have less fat and are generally easier to digest. The emphasis here is on the quality of fat, as unhealthy fats actively undermine gut health by disrupting the microbiome and promoting inflammation rather than simply being difficult to digest. Probiotic-rich fermented foods are a cornerstone of modern dietary strategies for digestive health, acting as natural conduits for introducing beneficial microorganisms into the gut. These foods contain live bacteria or yeast that, when consumed in adequate quantities, contribute to the gut microbiome, helping to strengthen existing beneficial communities and counteract dysbiosis, an imbalance or deficit of healthy microbes. The health benefits conferred by probiotics are multifaceted, operating through several key mechanisms within the gastrointestinal tract and beyond. Competitive exclusion of pathogens. Probiotic strains actively compete with harmful pathogens for adhesion sites on the intestinal lining and for available nutrients. By occupying these ecological niches, They make it difficult for pathogenic bacteria to colonize, survive, and exert their detrimental effects. Production of antimicrobial compounds. Many probiotic species synthesize and secrete a range of antimicrobial substances. These include short-chain fatty acids, SCFAs, organic acids such as lactic, acetic, and butyric acid, hydrogen peroxide, and bacteriocins. These compounds can directly inhibit the growth of harmful bacteria and contribute to a lowered acidic intestinal pH, which is less favorable for many pathogens. Enhancement of intestinal barrier function. A healthy gut barrier is crucial for preventing the translocation of harmful microbes and toxins from the gut lumen into the bloodstream. Probiotics contribute to this barrier integrity by enhancing mucus production and increasing the expression of tight junction proteins, which seal the spaces between intestinal epithelial cells. Immunomodulation. The gut microbiome is intimately linked with the immune system, with a significant portion of immune cells residing in the gut. Probiotics play a vital role in modulating both innate and adaptive immune responses, helping to train the immune system to recognize and eliminate harmful microbes while maintaining a tolerant response to beneficial commensals. This immune modulation can help regulate inflammatory responses within the gut and systemically nutrient production and absorption. Probiotics assist in the breakdown and absorption of certain nutrients and medications. They can also produce important nutrients as byproducts, including specific B vitamins, riboflavin, folate, B12, and vitamin K. Their activity can also mitigate nutritional intolerances, such as lactose intolerance, by producing the lactase enzyme, neurotransmitter. Synthesis. Emerging research suggests that certain probiotic strains can contribute to the production of neurotransmitters, influencing the complex communication pathways of the gut-brain axis, which can impact mood and mental well-being. The most frequently studied and recommended probiotic genera include Lactobacillus, for example, L. acidophilus, L. rhamnosus, L. caesae, L. plantarum, and Bifidobacterium, for example, B. lonium, B. breve, B. bifidum. Each strain may offer unique benefits, underscoring the complexity of probiotic efficacy. Fermented foods and beverages offer a natural and diverse means of incorporating probiotics into the diet. However, it is crucial to verify that products contain live and active cultures, as food processing, particularly pasteurization, can destroy these beneficial microorganisms. Key fermented foods recognized for their probiotic content include yogurt and kefir. These fermented dairy products are widely recognized sources of probiotics. Kefir, a fermented milk drink, is particularly noted for its ability to improve the diversity of gut bacteria and has been associated with improvements in gastrointestinal symptoms. Its lower lactose content compared to other dairy products also makes it a suitable option for individuals with lactose sensitivity. Kimchi. This spicy Korean dish, made from fermented cabbage and other vegetables, is rich in lactobacilli species, fiber, vitamins, minerals, and antioxidants. It is reported to contain more varieties of probiotics than sauerkraut and can improve digestion, reduce cholesterol, and strengthen the immune system. Sauerkraut. Fermented cabbage, with its lactic acid bacteria, contributes to an improved gut microbiome due to the retention of beneficial bacteria throughout the fermentation process. Unpasteurized varieties are preferred for maximum probiotic benefit, kombucha, a carbonated, fermented tea beverage containing yeast and bacteria. Its probiotic and antioxidant properties may help reduce gut dysbiosis. However, the exact probiotic benefits can vary significantly by brand and batch. Miso, a smooth paste made from fermented soybeans. Miso contains probiotics that aid digestion, gut health, immune function, blood sugar regulation, and may reduce allergy risk. Tempeh, also made from fermented soybeans. Tempeh is high in fiber and fermented using fungi and lactobacillus strains. However, many commercial tempeh products are pasteurized and cooked, which can reduce their active probiotic content. Other sources of probiotics include cottage cheese, miso soup, pickles, and pickle juice. The clinical utility of probiotics and fermented foods in managing various digestive conditions is an active area of research, with promising, though sometimes inconsistent, findings. Irritable bowel syndrome, IBS. Probiotics have been extensively studied for their potential to alleviate IBS symptoms such as bloating, abdominal pain, and bowel movement irregularities. While the evidence base can be conflicting due to the heterogeneity of study designs, probiotic strains, and patient populations, several specific strains have shown promise. For instance, Lactobacillus acidophilus, NCFM, may help reduce abdominal pain, and Saccharomyces boulardii has shown improvements in diarrhea predominant. IBS, Bifidobacterium lactis, BB12, has been linked to increased bowel movements, while Bifidobacterium bifidum, MIMBB75, even in a heat and activated form, and Bifidobacterium infantis, 35,624, have demonstrated improvements in abdominal pain and overall IBS symptoms. Bacillus coagulans, unique IS2, has also been associated with reduced abdominal pain and normalized bowel movements. And Lactobacillus plantarum LP299V with decreased abdominal pain and intestinal gas. A meta-analysis of randomized, controlled trials indicated that fermented foods, particularly fermented milk, had a statistically significant effect in improving global IBS symptoms. Although specific improvements in abdominal pain or bloating were not consistently observed across all studies. Inflammatory bowel disease, IBD, for IBD, which includes ulcerative colitis and Crohn's disease, probiotic treatment trials have yielded mixed results. While some studies on Crohn's disease have not shown a consistent remission effect, probiotic consumption, especially with multi-strain preparations, appears to be more effective in inducing or maintaining remission in ulcerative colitis patients. Probiotics are believed to contribute to reducing inflammation and improving gut barrier function in IBD, antibiotic-associated diarrhea, AAD. Probiotics are widely investigated for preventing AAD, a common complication of antibiotic use that disrupts the gut microbiome. Specific strains like Lactobacillus, rhamnosus, GG-LGG, and Saccharomyces boulardii have shown promise in reducing the risk of AAD, particularly in children. Some reviews suggest that starting probiotic treatment within 2 days of the first antibiotic dose can be beneficial. However, it is important to note that not all fermented foods or probiotic strains are equally effective. For example, a specific trial on kefir did not demonstrate a preventative role for AAD in children. Other potential benefits. Active research is exploring the potential benefits of probiotics in a wide array of other conditions, including atopic dermatitis, acne, cavities, gum disease, vaginal and urinary tract infections, H. pylori, and C. difficile, infections, small intestinal bacterial overgrowth, SIBO, and broader systemic effects on mood, pain, tolerance, mental acuity, fatigue, inflammation, immune response, metabolism, blood sugar regulation, fat storage, hypercholesterolium, and obesity. While these areas show promise, further robust human clinical trials are needed to draw definitive conclusions. To maximize the digestive benefits of probiotic-rich foods, particularly the viability of live cultures, and to ensure safety, specific preparation and consumption guidelines should be followed, ensuring live cultures for commercially available fermented foods. It is paramount to check labels for declarations of live and active cultures. Many processed fermented products undergo pasteurization, a heat treatment that, while ensuring shelf stability and safety by killing harmful bacteria, also inactivates or destroys the beneficial live microorganisms that confer probiotic benefits. Therefore, opting for unpasteurized or refrigerated varieties is generally recommended when seeking probiotic advantages. Home fermentation safety. For those undertaking home fermentation, strict adherence to safety protocols is critical to prevent the growth of harmful pathogens and ensure the proliferation of beneficial cultures. Key safety measures include pH control. The pH level of fermented foods must drop below 4.6 to successfully eliminate potential pathogens. This should be verified using a digital pH meter or accurate pH test strips, as visual appearance alone is insufficient to guarantee safety. Temperature regulation. Maintaining a consistent and proper temperature throughout the fermentation process is crucial for the good microorganisms to thrive. Fermenting on a kitchen counter is generally not recommended due to temperature fluctuations. A controlled water bath incubator is preferable. Time monitoring. Fermented foods must reach the target pH within a specified time frame to be considered safe. For instance, dairy products should reach a pH of 4.6 or less within 48 hours. Salt selection and ratio. Unrefined salts, like sea salt or kosher salt, are recommended, while iodized salt should be avoided, as iodine can inhibit beneficial bacteria and cause discoloration. Precision in the salt-to-water ratio is paramount. Too much salt can kill all bacteria, while too little allows harmful bacteria to survive. A general guideline is 1 to 3 tablespoons of salt per liter of water. Cleanliness, starting with clean, sterile jars, and ensuring overall hygiene throughout the process is fundamental. Recommended serving sizes and consumption tips. A study suggests that consuming 4 to 6 servings of fermented foods daily can be powerful for reducing inflammation and increasing gut bacteria diversity, though even 1 serving a day offers benefits. Recommended serving sizes include 2 tablespoons of sauerkraut or kimchi, 1 cup of plain kefir, 3/4 cup of plain yogurt, 1/2 cup of cultured cottage cheese, 1 cup of kombucha, or 1.5 ounces of fermented veggie brine. It is crucial to add fermented foods after cooking, as heat will destroy the live and active cultures. For individuals new to fermented foods or those with pre-existing gut issues, it is advisable to start with a smaller portion, such as half a serving size, and gradually increase intake as the body adapts and tolerates the introduction of these probiotic-rich foods. Digestive enzymes are specialized proteins that are indispensable for the efficient breakdown of food into absorbable nutrients. While the human body naturally produces a comprehensive array of these enzymes in various parts of the digestive system, including the mouth, stomach, and small intestines, certain foods also contain natural digestive enzymes that can supplement this process. The pancreas is particularly noteworthy as the enzyme powerhouse, secreting the majority of crucial digestive enzymes into the small intestine. A deficiency in the body's own enzyme production, such as an exocrine pancreatic insufficiency, EPI, can lead to maldigestion, nutrient malabsorption, and associated symptoms like bloating, cramping, and diarrhea. The primary categories of digestive enzymes and their functions are amylase. This enzyme is responsible for breaking down complex carbohydrates and starches into simpler sugar molecules, such as glucose and maltose. Protease. Proteases work to break down proteins into smaller fragments, including peptides and individual amino acids, which are the building blocks of proteins. Lipase enzymes specialize in breaking down dietary fats, triglycerides, into smaller fatty acids and glycerol, which can then be absorbed beyond these primary enzymes. Others play specific roles. Lactase. Produced in the small intestine, lactase breaks down lactose, the natural sugar found in milk. A deficiency in lactase leads to lactose intolerance, causing digestive discomfort upon dairy consumption. Alpha-galactosidase. Although not naturally produced by the human body, this enzyme is available in supplements and can help break down complex carbohydrates present in beans, legumes, and certain vegetables, thereby reducing gas and bloating. Several foods naturally contain digestive enzymes that can contribute to improved digestion. Pineapple bromelain. Pineapples are rich in a group of proteases, collectively known as bromelain. Bromelain aids in breaking down proteins into smaller peptides and amino acids, enhancing overall digestion and nutrient absorption. Studies suggest it may be particularly helpful for individuals with pancreatic insufficiency and can protect the gut from harmful bacteria. Bromelain also possesses natural anti-inflammatory properties that can reduce irritation in the digestive tract. Papaya, papain, 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 papayas contain papain, another potent protease that assists in protein digestion. Small studies indicate that papaya-based formulas may help ease IBS symptoms like constipation and bloating. It is important to note that unripe papaya can be harmful for pregnant women due to its latex content. Kiwifruit, actinidin. Kiwifruit contains actinidin, a proteolytic enzyme that significantly enhances the digestion of various food proteins, including those from meat, fish, eggs, legumes, and cereals. Research suggests actinidin may be particularly beneficial for individuals with compromised gastric function or delayed gastric emptying by accelerating protein hydrolysis and gastric emptying. Ginger, zingabane. Ginger contains zingabane, a protease effective at hydrolyzing connective tissue proteins. Beyond its enzymatic content, ginger itself can aid digestion by promoting food movement through the stomach and stimulating the body's own production of digestive enzymes like amylases and lipases. Mangoes are rich in amylases, enzymes that break down complex carbohydrates from starch into simpler sugars. The activity of these amylases increases as the fruit ripens, contributing to its sweetness. Raw honey. Raw honey contains a variety of digestive enzymes, including diastases, breaking down starch, amylases, breaking down starch, invertases, breaking down sucrose, and proteases, breaking down proteins. Bananas. Bananas contain amylase and maltase, which assist in carbohydrate digestion. Avocados are unique for containing lipase, an enzyme that specifically aids in the digestion of fats. Fermented foods, sauerkraut, kimchi, kefir, miso. Beyond their probiotic content, fermented foods like sauerkraut, kimchi, kefir, and miso acquire various digestive enzymes through the fermentation process, which contribute to their digestive benefits. The enzymatic content and activity of foods are highly sensitive to processing and temperature. Heat exposure, such as that incurred during cooking, can denature and inactivate these fragile protein structures, significantly reducing or destroying their digestive benefits. For example, to maximize the benefits of papain in papaya or bromelain in pineapple, these fruits should be consumed ripe and uncooked. Similarly, raw or unpasteurized honey and sauerkraut are preferred over their processed counterparts, as heating can destroy their beneficial enzymes. Furthermore, the body's own production of digestive enzymes is finite. Overeating can strain the digestive organs, forcing them to generate additional hormones and enzymes to cope with the excessive food load. This can lead to a depletion of available enzymes, resulting in delayed digestion and discomfort. Therefore, consuming enzyme-rich foods in their raw state and practicing mindful portion control can support the body's natural digestive processes beyond macronutrients. A spectrum of essential vitamins and minerals plays critical, albeit often less recognized, roles in maintaining the structural integrity, functional efficiency, and overall health of the digestive system. These micronutrients act as cofactors for enzymatic reactions, support tissue repair, and influence the gut microbiome and immune responses. Vitamin A, also known as retinol, is crucial for maintaining the health of the gastrointestinal tract, lining and nourishing the mucosal tissue that lines the gut. This mucosal membrane is vital for normal digestion and acts as a protective barrier. A deficiency in vitamin A can compromise the integrity of the intestinal lining, making it harder for nutrients to pass through and potentially altering the structure of the gut microbiota. Vitamin A, being a fat-soluble vitamin, is absorbed in the small intestine, and its absorption is significantly enhanced by the concurrent presence of dietary fat, which stimulates pancreatic enzyme and bile salt secretion. Vitamin A also possesses antioxidant properties, helping to protect cells from damage by free radicals. Rich food sources of vitamin A include orange-hued vegetables such as carrots, pumpkin, and sweet potatoes, as well as dark leafy greens like kale, spinach, and broccoli. Animal-derived sources include eggs, milk, liver, and some types of fish like herring and salmon. Many breakfast cereals and margarines are also fortified with vitamin A beta-carotene. Found abundantly in colorful fruits and vegetables is a precursor that the body converts into vitamin A. The recommended daily intake for adults is 900 micrograms mcg for men and 700 mcg for women. Most individuals consuming a varied diet obtain sufficient vitamin A, making supplementation generally unnecessary unless a deficiency or malabsorption condition, such as Crohn's or celiac disease, is present. Often referred to as the sunshine vitamin, vitamin D is widely recognized for its role in bone and teeth health due to its promotion of calcium absorption in the gut. However, its importance extends to digestive health by improving and maintaining a rich gut flora. Research indicates that vitamin D deficiency can trigger autoimmune disorders by altering the gut microbiome and compromising the intestinal epithelial barrier. Low vitamin D levels have also been specifically linked to inflammatory bowel diseases like IBS and Crohn's disease. Like vitamin A, vitamin D is a fat-soluble vitamin, and its absorption in the small intestine is enhanced by the presence of dietary fat. Primary food sources of vitamin D include fatty fish such as salmon, trout, and sardines, as well as egg, yolks, and liver. Fortified foods like milk and cereals also contribute to intake. Mushrooms exposed to UV light can also be a source. Endogenous synthesis in the skin through exposure to UVB radiation from sunlight remains a significant source. The recommended dietary allowance, RDA, for adults is 15 to 20 mcg. Due to the difficulty of achieving adequate intake solely through diet, vitamin D supplementation is often recommended, especially during winter months or for populations with limited sun exposure. Vitamin C, a water-soluble vitamin and potent antioxidant, is essential for the proper functioning of both the immune and digestive systems. Its role in digestion begins in the mouth, where it contributes to strong teeth and gums, facilitating effective chewing, the crucial first step in digestion. Beyond the oral cavity, vitamin C significantly aids in the absorption of dietary iron, which is necessary for maintaining energy levels. It also plays a vital role in boosting collagen production. Collagen is a key structural protein found in the tissues that line and hold together the digestive tract, contributing to its integrity and repair. As an antioxidant, vitamin C neutralizes free radicals and toxins and can attenuate inflammatory responses. Most vitamin C is absorbed in the distal small intestine. Excellent food sources of vitamin C include a wide variety of fruits such as oranges, grapefruit, strawberries, papayas, black currants, and kiwi fruit. Vegetables rich in vitamin C include broccoli, leafy green vegetables like cabbage, capsicum, spinach, Brussels sprouts, tomatoes, and potatoes. Liver is also a source. The recommended daily intake for adults typically ranges from 40 to 120 milligrams, with an average protective dose of 70 to 150 milligrams daily, while supplements are available. The emphasis for most individuals should be on obtaining vitamin C through a healthy diet, rich in fruits and vegetables. The B group vitamins are a complex of 8 water-soluble essential nutrients, each playing distinct yet interconnected roles, fundamental to metabolic processes and overall physiological function. They are crucial for the breakdown, absorption, and utilization of macronutrients, carbohydrates, proteins, and fats from food, effectively converting them into usable energy ATP for the body's cells. Beyond energy metabolism, B vitamins are vital for red blood cell formation and maintaining healthy brain and nerve cell function. Specific B vitamins and their roles in digestion include B1 thiamine, helps the body break down carbohydrate molecules from food into ATP. B3 niacin, important for converting nutrients into ATP and supports the proper functioning of the digestive system. Skin and nerves. B6 pyridoxine assists the digestive system in breaking down protein, carbohydrates, and fats, and plays a role in immune function. B7 biotin, key for breaking down fats, carbohydrates, and proteins. B12 cobalamin, essential for red blood cell production, DNA synthesis, and the function and development of brain and nerve cells. A deficiency can lead to anemia. Vitamin B12 is unique among B vitamins as it is stored in the liver for several years, and its absorption in the distal ileum requires intrinsic factor, a protein secreted by the stomach. B9 folate helps make genetic material in red blood. CELLSB vitamins are widely distributed in various food sources, including fish, poultry, meat, dairy products, eggs, leafy greens, beans, whole grains, nuts, and seeds. Fortified breakfast cereals are also common sources. Notably, vitamin B12 is almost exclusively found in animal products, making supplementation a consideration for vegetarians and vegans. While most individuals can obtain sufficient B vitamins from a balanced diet, supplements may be beneficial for certain populations, such as older adults, those on restrictive diets, for example, keto, or individuals with digestive issues like Crohn's disease, who may experience very low B12 levels due to malassor. 2 Magnesium is an essential mineral involved in over 300 enzymatic processes throughout the body, many of which are directly relevant to digestive health. It plays a crucial role in the breakdown of food and the absorption of nutrients. Key mechanisms of magnesium in digestion include gut motility and muscle relaxation. Magnesium is essential for the proper functioning of the smooth muscles in the intestines, facilitating peristalsis, the wave-like contractions that move food along the digestive tract. It acts as a natural muscle relaxant, which can alleviate gastrointestinal spasms and cramping, promoting smoother digestion. Laxative effect. Certain forms of magnesium, particularly magnesium oxide and magnesium citrate, function as osmotic laxatives. They draw water into the intestines, which softens the stool and increases its bulk, making it easier to pass and effectively relieving constipation and associated bloating. Gut microbiome and inflammation. Preliminary research suggests that magnesium may influence the diversity of the gut microbiota. Low or deficient levels of magnesium have been linked to decreased levels of beneficial bacteria, such as Bifidobacterium species, and can lead to compromised gut integrity and higher levels of inflammatory proteins. Magnesium's anti-inflammatory properties can also help alleviate symptoms in inflammatory conditions like IBD. Hydrochloric acid production. Magnesium plays a role in the production of hydrochloric acid in the stomach, which is vital for breaking down food and neutralizing harmful bacteria. It can also help neutralize excess stomach acid, providing relief from heartburn. Magnesium is widely available in various foods, including leafy green vegetables, spinach, Swiss chard, kale, nuts, almonds, cashews, pumpkin seeds, chia seeds, legumes, black beans, edamame, dark chocolate, whole grains, brown rice, seafood, meat, and dairy products. The recommended dietary allowance, RDA, for adults is 400 to 420 milligrams daily. For men, and 310 to 320 milligrams for women. It is important to note that high doses of magnesium, particularly from supplements, can cause diarrhea, nausea, and cramping. Individuals with digestive disorders like IBD or celiac disease often have lower magnesium levels due to decreased absorption and increased losses from diarrhea, making supplementation a potential consideration. Under professional guidance, potassium is an essential mineral and electrolyte crucial for numerous bodily functions, including those vital for digestion. Its primary role involves maintaining normal fluid levels inside cells, working in conjunction with sodium to preserve physiological balance in the context of digestion. Potassium contributes to muscle contraction and nerve function as an electrolyte. Potassium carries a small electrical charge that activates various cell and nerve functions, including the contraction of muscles throughout the body. This includes the smooth muscles of the digestive tract, which are responsible for peristalsis and overall gut motility. Fluid balance. By helping to move nutrients into cells and waste products out of cells, potassium plays a direct role in cellular fluid balance. This systemic fluid regulation indirectly supports optimal stool consistency and ease of passage. Blood pressure regulation. A diet rich in potassium helps to offset some of sodium's harmful effects on blood pressure, contributing to overall cardiovascular health. While not a direct digestive mechanism, systemic health contributes to optimal digestive function. Potassium is widely distributed in various food sources, making it relatively easy to obtain through a balanced diet. Rich sources include leafy, green vegetables, spinach, collards, vine fruits, grapes, blackberries, tomatoes, cucumbers, zucchini, eggplant, pumpkin, root vegetables, carrots, potatoes, and citrus fruits, oranges, grapefruit. It is also moderately abundant in bananas, apricots, melons, nuts, seeds, meat, milk, beans, peas, and lentils. The adequate intake AI for adult men is 3,800 milligrams per day, and for adult women, it is 2,800 milligrams a day. High potassium intakes, particularly from supplements, can cause gastrointestinal discomfort, including ulceration and perforation, highlighting the importance of obtaining it primarily from food sources under normal circumstances. Zinc is a vital trace mineral, meaning the body requires it in small amounts. Yet, it is indispensable for nearly 100 enzymes to carry out crucial chemical reactions. Its multifaceted roles include DNA creation, cell growth, protein building, and supporting a healthy immune system. In the context of digestive health, zinc is particularly important for gut barrier integrity. Zinc significantly enhances the function and integrity of the gastrointestinal epithelial barrier. The intestinal barrier is maintained by tight junctions between epithelial cells, which regulate permeability and prevent the passage of potentially noxious materials from the gut lumen into the bloodstream. Zinc deficiency can induce leakiness in these tight junctional seals, compromising the barrier function. Immune function. Zinc supports the growth and normal functioning of immune cells, helping the body defend against viruses and bacteria. It also contributes to immune cell activity that combats inflammation, which is critical for maintaining gut health and enzymatic systems. As a component of numerous enzyme systems, zinc indirectly supports various digestive processes. Rich food sources of zinc include shellfish, oysters, crab, lobster, beef, poultry, pork, legumes, nuts, seeds, and whole grains. Fortified breakfast cereals also contribute to zinc intake. It is important to note that while plant-based sources of zinc are available, they often contain phytates that can bind to the mineral, potentially lowering its absorption. The recommended dietary allowance, RDA, for adults is 11 milligrams per day for men and 8 milligrams for women. Zinc deficiency is relatively rare in developed countries, but can occur in individuals with digestive disorders such as inflammatory bowel diseases or those who have undergone gastrointestinal surgery due to impaired absorption or increased losses from chronic diarrhea. Excessive zinc intake from supplements can interfere with the absorption of other essential minerals like iron and copper, and may cause side effects such as nausea and vomiting. Therefore, obtaining zinc primarily through a balanced diet is recommended, with supplementation considered only under professional guidance for confirmed deficiencies. Chronic inflammation within the gut is a significant contributor to various digestive disorders and systemic health issues. Dietary strategies focused on incorporating anti-inflammatory compounds, can play a crucial role in maintaining gut homeostasis and promoting overall well-being. Polyphenols are a vast group of natural chemical compounds found abundantly in plants, responsible for their vibrant colors and distinct flavors. Beyond their sensory attributes, polyphenols possess potent antioxidant and anti-inflammatory properties, making them invaluable for gut health. They combat oxidative stress by neutralizing harmful free radicals and preventing cellular damage, thereby reducing inflammation, a critical mechanism by which polyphenols benefit the gut is through their direct and indirect modulation of the gut microbiome. They can suppress the growth of pathogenic bacteria while selectively stimulating the proliferation of beneficial microbial strains. The interaction of polyphenols with dietary fibers further influences their bioavailability and efficacy within the digestive tract. For instance, flavonols found in cocoa have been shown to directly promote the growth of beneficial gut bacteria. Polyphenols are categorized into various classes, each with unique food sources: fruits, berries, red, blue, purple, grapes, plums, pomegranates, cranberries, apples, cherries, oranges, and lemons are rich sources of diverse polyphenols, including anthocyanins, flavanthrals, flavonones, and phenolic acids. Vegetables: leafy greens, broccoli, kale, spinach, red cabbage, onions, carrots, peppers, tomatoes, eggplant, and sweet potatoes contribute various flavonoids and phenolic acids. Nuts and seeds, flax seeds, and sesame seeds contain lignans, a type of POL, YPHENOL. Legumes and whole grains also provide lignans and phenolic acids. Beverages: coffee, tea, especially green tea, and red wine are notable sources. Cocoa, dark chocolate, rich in flavonols. Spices: turmeric, curcumin, and gingerols are potent sources. Discussed in detail below, carotenoids and flavonoids are two prominent classes of plant compounds that contribute significantly to the anti-inflammatory capacity of the diet. Carotenoids. These are fat-soluble pigments responsible for the vibrant yellow, orange, and red colors of many fruits and vegetables. Common carotenoids include beta-carotene, lutein, and lycopene. Their primary benefit lies in their potent antioxidant activity, protecting cells and tissues from damage caused by free radicals and singlet oxygen. This antioxidant action directly contributes to reducing inflammation. Carotenoids can also influence gene expression and cellular signaling pathways, further contributing to their anti-inflammatory effects. Food sources. Carotenoids are abundant in yellow-orange fruits and vegetables such as carrots, pumpkins, peppers, tomatoes, mangoes, cantaloupe, and sweet potatoes. They are also present in dark green leafy vegetables like spinach and kale, where their color is masked by chlorophyll. Flavonoids. As a subclass of polyphenols, flavonoids share many of their beneficial properties, including strong antioxidant and anti-inflammatory effects. They are extensively metabolized by the gut microbiota and host tissues after consumption. And these metabolic transformations can influence their biological activity. Flavonoids can modulate intestinal immune function, including influencing T-cell differentiation and cytokine production. Specific types and sources: anthocyanins. These pigments give red, blue, and purple berries, purple grapes, red apples, and cherries their color and antioxidant properties. FLA VAN-3-OLS found in tea, cocoa, berries, grapes, and apples. Flavonols present in kale, onions, broccoli, apples, berries, and tea. Flavones common in herbs like parsley and thyme, as well as celery and hot peppers. Flavonones abundant in citrus fruits like oranges, lemons, and grapes, contributing to their bitter taste and offering antioxidant benefits. Isoflavones primarily found in soybeans, soy milk, tofu, and other soy-based products, as well as legumes, among the vast array of anti-inflammatory plant compounds. Curcumin from turmeric and gingerols from ginger stand out for their extensively researched properties and significant impact on gut inflammation. From turmeric, curcumin is the primary polyphenolic compound derived from turmeric, curcuma longa, a widely used culinary spice in traditional medicine. It exhibits a broad spectrum of pharmacological properties, including potent anti-inflammatory, antioxidant, and anti-cancer effects. In the context of gut health, curcumin has been shown to modulate the gut microbiota composition, favoring the growth of beneficial bacteria such as Bifidobacterium, Lactobacillus, and butyrate-producing bacteria, while decreasing the abundance of potentially harmful strains. This modulation contributes to improved gut health and homeostasis. At a molecular level, curcumin's anti-inflammatory actions involve the inhibition of key inflammatory pathways, such as NFB activation and the suppression of pro-inflammatory mediators like COX-2, LOX, IONOS, TNF, alpha, IL-1 beta, and IL-6. It is noteworthy that curcumin's therapeutic application is often limited by its poor aqueous solubility, rapid metabolism, and low systemic bioavailability. However, its interaction with the gut microbiota plays a crucial role in its metabolism and overall efficacy. This suggests that the gut microbiome not only mediates the effects of prebiotics, but also actively transforms and enhances the bioavailability of other complex plant compounds like polyphenols, making them more effective. This highlights a complex interplay where the efficacy of consuming anti-inflammatory foods like turmeric may depend on the individual's gut microbiota composition and its capacity to metabolize these compounds. Gingerols from ginger, Zingiber officinale, is another ancient herb known for its medicinal properties, particularly its anti-inflammatory and antioxidant functions. The primary phenolic compounds responsible for these effects in fresh ginger are gingerols, along with related compounds like shagols, peridols, and zingeroni. Gingerols can alleviate inflammation by inhibiting the activation of key signaling pathways such as AKT and NFB, leading to a decrease in pro-inflammatory cytokines and an increase in anti-inflammatory cytokines. Clinical studies have shown that ginger supplementation can favorably affect perceptions of pain, functional capacity, and inflammatory markers like IL-6, IFN, gamma, TNF-alpha, and C-reactive protein. Similar to curcumin, gingerols also face challenges with low bioavailability, further underscoring the importance of understanding how gut microbiota might influence their efficacy. While certain foods and dietary components actively promote digestive health, others can significantly undermine it, leading to discomfort, dysbiosis, and chronic conditions. Beyond diet, lifestyle factors such as stress and sleep patterns exert profound influences on the gastrointestinal system. Processed and ultra-processed foods, UPFs, represent a significant threat to digestive health. These industrial formulations are typically low in beneficial dietary fiber, which is crucial for gut regularity and microbiota health, and often high in unhealthy fats, refined sugars, artificial additives, and excessive sodium. The inherent composition of UPFs makes them difficult to digest, leading to common symptoms such as bloating, gas, and general discomfort. Beyond immediate symptoms, UPFs profoundly disrupt the delicate balance of the gut microbiome. They promote a pro-inflammatory environment, reduce microbial diversity, and can increase intestinal permeability, contributing to a leaky gut phenomenon. This microbial imbalance and compromised barrier function can lead to systemic inflammation and oxidative stress, which are hallmarks of various chronic diseases. UPF consumption has been linked to a reduction in the production of beneficial short-chain fatty acids, SCFAs, by gut bacteria. Furthermore, additives like emulsifiers and artificial sweeteners, commonly found in UPFs, can directly harm the gut lining and fuel inflammation, while industrial processing techniques such as the Maillard reaction and hydrogenation can produce pro-oxidant and carcinogenic compounds. Examples of UPFs to limit include processed meats, bacon, smoked sausages, cured hams, which are high in nitrates and linked to increased colorectal cancer risk. Many processed snack bars, often disguised as healthy options, are essentially candy bars in disguise due to their high content of emulsifiers, artificial fibers, and seed oils. Store-bought salad dressings, flavored yogurts, instant noodles, and granolas with added sugars also fall into this category, contributing to gut microbial disruption and inflammation. The pervasive nature of these hidden inflammatory triggers means that a careful scrutiny of ingredient lists beyond obvious junk food is essential for maintaining gut health. Diets characterized by high sugar intake pose a significant threat to gut health and systemic well-being. Excessive sugar consumption can lead to an imbalance in the intestinal flora, specifically causing an overgrowth of certain bacterial species like firmicutes and proteus. Delicate equilibrium dysbiosis. This microbial imbalance is implicated in the root causes of various metabolic and inflammatory conditions, including weight gain, inflammation of the intestines, non-alcoholic fatty liver disease, NAFLD, and type 2 diabetes, beyond natural sugars. Artificial sweeteners, and sugar alcohols such as sorbitol, mannitol, and xylitol, commonly found in diet foods and sugar-free products, can also cause significant digestive distress. These compounds are often poorly absorbed in the small intestine and can ferment in the colon, leading to gas, bloating, cramping, and diarrhea. High fructose corn syrup, a prevalent sweetener in many processed foods and sodas, can also contribute to gastrointestinal upset. The impact of high sugar intake extends to increasing intestinal permeability and deteriorating the intestinal barrier, further compromising gut health. Unhealthy fats, particularly those found in fried foods, excessive saturated fats, and certain refined seed oils, are detrimental to digestive function. These fats are inherently harder for the body to break down and absorb, leading to prolonged digestion times and common symptoms such as stomach pain, heartburn, bloating, and a general feeling of sluggishness. A high intake of these fats can overwhelm the digestive system, and, if unabsorbed, they can collect in the small intestines and colon, drawing in water and resulting in diarrhea. Chronic fat malabsorption can lead to malnutrition due to the body's inability to absorb essential nutrients, including fat-soluble vitamins. Beyond immediate digestive discomfort, unhealthy fats contribute to systemic issues. In the liver, can lead to non-alcoholic fatty liver disease, NAFLD, characterized by inflammation and potential liver cell damage. Refined seed oils, such as canola, soy, and corn oil, are often high in omega-6 fatty acids and can become oxidized during processing, contributing to gut lining damage and inflammation. This highlights that the negative impact of unhealthy fats goes beyond mere digestibility, actively undermining gut barrier integrity and fostering a pro-inflammatory state. Certain foods, while potentially nutritious for some, can trigger digestive issues in others due to individual sensitivities or compositional factors. Red meat, particularly high-fat cuts, can be harder to digest due to its high fat content and relatively low fiber. Excessive consumption may also negatively impact the balance of gut bacteria. Limiting red and processed meats has been associated with a reduced risk of ulcerative colitis, flares, and may contribute to overall cancer prevention. Dairy. For individuals with lactose intolerance, dairy products such as milk, cheese, and yogurt can cause significant digestive discomfort, including bloating, gas, and diarrhea, typically occurring 30 to 90 minutes after consumption. This intolerance stems from a deficiency in the enzyme lactase, which is required to break down lactose milk sugar in the small intestine. Unbroken down lactose then travels to the colon, where it ferments with bacteria, producing uncomfortable symptoms. Lactose intolerance is particularly prevalent among patients with IBD, affecting 44 to 70% of this population. High-fat dairy products may also independently slow down digestion. For sensitive individuals, opting for lactose-free dairy alternatives or using lactase supplements can help manage symptoms, while many individuals enjoy spicy foods without issue. For some, these can be significant triggers for digestive discomfort. Spicy foods, particularly those containing capsaicin, for example, chilies, can irritate the mucosal lining of the gut and trigger heartburn or indigestion. Similarly, highly acidic foods and beverages can exacerbate symptoms. Citrus fruits, tomatoes, salad dressings, and sodas may trigger heartburn and acid reflux by increasing stomach acid production. Caffeinated drinks, such as coffee and tea, can also contribute to increased stomach acid, leading to similar issues. For those prone to acid reflux or a sensitive stomach lining, moderating the intake of these foods and opting for milder seasonings or less acidic beverages is advisable. Artificial sweeteners, commonly found in diet foods and beverages, can unexpectedly lead to digestive problems for many individuals. These non-caloric sweeteners, such as aspartame and sucralose, are often poorly absorbed in the small intestine and can reach the colon, where they are fermented by gut bacteria. This fermentation process can result in uncomfortable symptoms like cramping, gas, and diarrhea. Furthermore, research suggests that artificial sweeteners may negatively alter the composition of the gut microbiome and potentially promote inflammation, contributing to broader gut dysbiosis. Both caffeine and alcohol, widely consumed substances, can exert significant negative impacts on digestive health through various mechanisms. Caffeine, as a stimulant. Caffeine directly increases gut motility, accelerating the rhythmic contractions of the muscles that propel contents through the gastrointestinal tract. While this can be beneficial for some experiencing constipation, for others, it can lead to loose stools or diarrhea and contribute to dehydration. Caffeine can also relax the lower esophageal sphincter, exacerbating acid reflux symptoms, and may increase stomach acid production, leading to heartburn. Its stimulating effects can also heighten jitteriness and anxiety, which are known to worsen symptoms of many gastrointestinal conditions, including IBS and IBD. Alcohol consumption can profoundly disrupt the delicate balance of the gut microbiome, leading to a state of dysbiosis where beneficial bacteria are diminished and potentially harmful ones proliferate. The metabolism of alcohol by gut microbes can produce toxic metabolites that signal between the gut, liver, and bloodstream. Furthermore, alcohol can compromise the integrity of the intestinal lining's protective mucus layer, leading to increased intestinal permeability or leaky gut. This allows toxins and microbial products to enter the bloodstream, triggering systemic inflammation and potentially increasing the risk of various cancers, including esophageal, colorectal, stomach, and liver cancers. Alcohol can also directly cause gastritis by overwhelming the stomach lining's enzymes, leading to breakdown and symptoms like nausea, vomiting, and diarrhea. For cancer prevention, limiting alcohol intake to no more than 1 drink per day for women and 2 for men is advised. Gluten, protein complex, found in wheat, barley, and rye, can be a significant trigger for digestive issues in a subset of the population. While celiac disease represents the most severe form of gluten sensitivity, an autoimmune condition where gluten consumption leads to damage of the small intestine lining, requiring complete avoidance. Other forms of sensitivity exist. For individuals with irritable bowel syndrome, IBS, gluten, or other wheat components, such as amylase inhibitors, and fructans, which are fermentable oligosaccharides, got disaccharides, monosaccharides, and polyols, or FODMAPs, can precipitate or exacerbate symptoms like abdominal pain and bloating. These short-chain carbohydrates are poorly absorbed in the small intestine and ferment in the colon, leading to gas and pain in sensitive individuals. For those with unexplained IBS with diarrhea, gluten avoidance may be recommended. The importance of personalized dietary assessment to identify individual triggers, which may involve exploring a low FODMAP diet under professional guidance. Beyond the specific foods consumed, the manner in which one eats can significantly influence digestive efficiency and comfort. Unhealthy eating habits can disrupt the natural rhythm of digestion and contribute to various gastrointestinal symptoms. Rapid eating is a common habit that can have several negative consequences for digestion. When individuals eat too quickly, they tend to swallow more air, which directly contributes to feelings of bloating and gas. Furthermore, insufficient chewing is a direct consequence of hurried eating. Proper chewing is the crucial first step in mechanical digestion, breaking down larger food particles into smaller, more manageable pieces that are easier for digestive enzymes to act upon. Saliva, which contains initial digestive enzymes, also needs adequate time to mix with food for optimal predigestion. Eating too quickly also interferes with the body's natural satiety signals. It takes approximately 20 minutes for the stomach to communicate fullness to the brain. When food is consumed rapidly, this signal is often missed, leading to overeating. This can result in uncomfortable fullness, reflux, and increased strain on the digestive organs. Practicing mindful eating, such as slowing down, thoroughly chewing food, and avoiding distractions during meals, can significantly improve digestive comfort and help regulate food intake. Consuming excessively large portion sizes places an undue burden on the entire digestive system. When a large volume of food is ingested at once, all digestive organs are forced to work harder, generating additional hormones and enzymes in an attempt to break down the substantial load. This increased workload can lead to a temporary depletion of digestive enzymes, resulting in delayed and inefficient digestion. The consequence of this delayed process is that food remains in the system for longer periods, increasing the likelihood that excess calories will be stored as fat. Furthermore, large portions can cause significant gut discomfort, including bloating, distension, and a feeling of being overly full. Consistent overeating can contribute to metabolic disorders and insulin resistance over time. Managing portion sizes is therefore a simple, yet effective strategy to alleviate digestive discomfort and support metabolic health. The intricate connection between the brain and the gut, often referred to as the gut-brain axis, means that psychological and physiological stressors can profoundly impact digestive health. Chronic stress and inadequate sleep are two pervasive lifestyle factors that can significantly disrupt gut function. Chronic stress is a powerful modulator of the gut-brain axis, exerting a detrimental influence on the digestive system. When the body is under stress, the sympathetic nervous system, responsible for the fight or flight response, is activated. This activation prioritizes immediate survival functions, diverting blood flow away from the digestive system towards muscles and the heart. Consequently, digestion slows down and bowel motility is inhibited, which can lead to issues like constipation. Chronic stress also elevates cortisol levels, a primary stress hormone, which has been linked to impaired brain functions and emotional dysregulation. Beyond these direct physiological effects, chronic stress can induce profound changes in the gut microbiome, leading to dysbiosis. This microbial imbalance often manifests as a decrease in the diversity of gut bacteria, a reduction in beneficial species such as Lactobacilli and Bifidobacterium, and an increase in pro-inflammatory or potentially harmful bacteria. This altered microbial landscape increases vulnerability to enteric infections and contributes to an excess of inflammatory mediators within the gut. A critical consequence of stress-induced dysbiosis is increased intestinal permeability, or leaky gut. When the gut barrier is compromised, potentially noxious materials like antigens, toxins, and pro-inflammatory molecules can translocate from the gut lumen into the bloodstream, triggering both local and systemic inflammation. This pathway explains why chronic stress can exacerbate symptoms and disease activity in various gastrointestinal conditions, including irritable bowel syndrome, IBS, inflammatory bowel disease, IBD, gastritis, gastroesophageal reflux disease, GERD, and ulcers. Therefore, effective stress management techniques such as deep breathing, meditation, yoga, and regular exercise are not merely beneficial for mental well-being, but are fundamental for maintaining digestive health. Sleep deprivation, whether acute or chronic, significantly impacts gut health through its intricate relationship with the gut microbiome and inflammatory pathways. The gut microbiota and circadian rhythms are closely intertwined, and disruptions to sleep can profoundly alter the composition and diversity of gut bacteria. Even brief periods of sleep restriction can lead to subtle shifts in the relative abundance of certain bacterial groups and a reduction in overall microbial diversity, which is generally associated with poorer gut health. This sleep deprivation-induced dysbiosis is directly linked to an increase in pro-inflammatory cytokines, for example, IL-1 beta, IL-6, TNF-alpha, gut barrier dysfunction, and systemic inflammation. The compromised gut barrier, similar to that seen in chronic stress, allows for increased translocation of bacterial products into the bloodstream, further fueling inflammatory responses. Furthermore, the changes in gut microbiota composition induced by sleep loss contribute to neuroinflammation, cognitive deficits, anxiety, and depression via the gut-brain axis. Sleep deprivation can also alter host metabolism, potentially contributing to issues like reduced insulin sensitivity, obesity, and an increased risk of diabetes. The relationship is bidirectional. While poor sleep leads to gut dysbiosis, certain gut bacteria and their metabolites can, in turn, influence sleep quality and fatigue, creating a cyclical pattern. This highlights that adequate, restorative sleep is not just a recovery process for the brain and body, but a critical factor in maintaining a healthy gut microbiome, preserving gut barrier integrity, and mitigating inflammation, all of which are fundamental for optimal digestive function, achieving and maintaining. Optimal digestive health necessitates a multifaceted approach that extends beyond simply identifying beneficial foods. It requires the adoption of holistic dietary patterns, mindful eating practices, gradual and personalized dietary adjustments, and an awareness of lifestyle factors and potential food-drug interactions. The most effective strategy for promoting digestive well-being is to embrace a holistic dietary pattern that emphasizes whole, unprocessed foods. This approach moves beyond focusing on individual superfoods to leveraging the synergistic effects of a diverse range of nutrients and compounds on the complex gut microbiome. Prioritizing whole, unprocessed, or minimally processed foods over ultra-processed options is fundamental. Whole foods naturally provide essential nutrients, a rich array of dietary fiber, and a complex matrix of compounds that collectively support a healthy and diverse gut microbiome. In contrast, ultra-processed foods, with their often high content of unhealthy fats, refined sugars, and artificial additives, actively disrupt gut flora and promote inflammation. A diet rich in fruits, vegetables, grains, and legumes can significantly and positively alter the composition of the digestive flora. This emphasis on plant-based foods, combined with lean protein sources, aligns with dietary patterns such as the Mediterranean diet. The Mediterranean-style diet, characterized by its abundance of vegetables, legumes, whole grains, nuts, seeds, fish, and lean poultry, is widely recommended for its benefits to gut health and its potent anti-inflammatory properties. This dietary pattern fosters microbial diversity and promotes the production of beneficial short-chain fatty acids, which are crucial for gut integrity and immune modulation. The focus on a dietary pattern rather than isolated foods is critical, because the overall matrix of food consumed and its long-term influence on the gut microbiome are more impactful than the effects of single dietary components. This holistic perspective provides a flexible and sustainable framework for long-term digestive health beyond what is eaten. How one eats profoundly impacts the digestive process. Adopting mindful eating practices can significantly enhance digestive efficiency and comfort. Chewing thoroughly. Digestion begins in the mouth, and proper chewing is the critical first step. Thoroughly breaking down food into smaller particles facilitates easier enzymatic action later in the digestive tract. Saliva, which contains initial digestive enzymes, also needs adequate time to mix with food for optimal pre-digestion. Eating slowly, rushing through meals can lead to swallowing excess air, contributing to bloating and gas. Eating slowly also allows the body's natural satiety signals to register. It takes approximately 20 minutes for the stomach to send fullness signals to the brain. Eating too quickly often bypasses this mechanism, leading to overeating and subsequent discomfort or reflux. Avoiding distractions, being present and aware during meals, rather than being distracted by screens or other activities, can improve the pleasure of eating and promote better digestion by allowing the body to focus on the task at hand. Smaller, Frequent meals. For some individuals, particularly those with conditions like IBD, consuming smaller, more frequent meals throughout the day instead of 3 large ones can reduce the digestive burden and alleviate symptoms. Introducing significant dietary changes, even beneficial ones, too rapidly can overwhelm the digestive system and lead to discomfort. A gradual approach is key to successful and sustainable dietary modification. Slow fiber introduction. When increasing dietary fiber intake, it is imperative to do so slowly over a period of several weeks. A sudden, substantial increase in fiber can result in undesirable side effects such as intestinal gas, cramping, bloating, and even diarrhea, or exacerbated constipation, if not accompanied by sufficient fluid intake. Adding just a few grams of fiber at a time and allowing the body several days to adjust before further increases enables the gut microbiome to adapt to the new dietary substrates, expanding diet after flares. For individuals managing chronic digestive conditions like inflammatory bowel disease, IBD, dietary adjustments are often necessary during periods of active inflammation or flares. During these times, easily tolerated, softer, cooked, and peeled fruits and vegetables, along with refined grains and pureed legumes, are often recommended. Once symptoms subside and the gut begins to heal, a gradual reintroduction of harder to digest fibers, including whole grains, raw nuts, and fruits with skins, can commence. This phased approach minimizes the risk of symptom recurrence and supports long-term dietary diversity, given the unique nature of each individual's digestive system and gut microbiome. A one-size-fits-all dietary approach is rarely effective for optimizing digestive health, particularly in the presence of chronic conditions. Tailored approaches. No single diet has been consistently proven to prevent or treat all digestive disorders. Dietary advice must be highly individualized, taking into account specific symptoms. Diagnosed conditions, for example, IBS, IBD, lactose intolerance, strictures, and personal tolerances. Keeping a detailed food diary can be an invaluable tool for individuals to identify their specific dietary triggers and understand how different foods affect their digestion. Role of professionals. Consulting with a registered dietitian or a healthcare provider specializing in gastroenterology is crucial for developing a personalized nutrition plan. These professionals can provide evidence-based guidance on managing complex dietary needs, such as navigating low-FODMAP diets to identify problematic carbohydrates in IBS, adjusting fiber intake during IBD flares, or addressing specific nutrient deficiencies that may arise from malabsorption or restrictive diets. Their expertise ensures that dietary modifications are safe, effective, and nutritionally adequate. The way food is prepared can significantly impact its digestibility and nutrient bioavailability, influencing how well it supports digestive health. Cooking. For fiber digestibility, cooking can make dietary fiber more digestible and enhance the absorption of several nutrients. Generally, shorter cooking times and lower temperatures are preferable for retaining the maximum nutritional content of foods. Steaming is often highlighted as an optimal cooking method for vegetables, as it uses low temperatures and helps preserve vitamins and minerals, while maintaining flavor and texture. Boiling, while potentially leading to nutrient leaching, can specifically decrease insoluble dietary fiber and increase soluble dietary fiber content in cruciferous vegetables, which may be a beneficial modification for individuals experiencing IBD flares or other conditions where insoluble fiber is poorly tolerated. Thoroughly cooking fruits and vegetables, whether by steaming or roasting, can also make them gentler and easier to tolerate for sensitive digestive systems, such as those with IBS-C. Soaking and sprouting for anti-nutrients. Many grains, legumes, nuts, and seeds contain naturally occurring compounds known as anti-nutrients, for example, lectins, tannins, protease inhibitors, calcium oxalate. These compounds can inhibit digestion and reduce the bioavailability of essential nutrients. Soaking these foods in water, often overnight, can significantly reduce these anti-nutrient compounds by up to 50% or more, thereby improving their digestibility and enhancing nutrient absorption. Adding a small amount of lemon juice or apple cider vinegar to the soaking water can further maximize these benefits. Sprouting, the process of germinating seeds, grains, or legumes, has been shown to further reduce phytate content by 37 to 81% and may also slightly degrade lectins and protease inhibitors. Boiling is another method that can help deactivate some anti-nutrients, particularly lectins and tannins. Combining these methods, for example, soaking followed by cooking, can have a compounded effect, leading to a substantial reduction in anti-nutrients and further enhancing nutrient digestibility, while minimizing gastrointestinal symptoms. Proper fermentation. For live cultures and safety, as detailed in section IV.4, safe and effective home fermentation requires meticulous attention to detail. This includes ensuring clean, sterile equipment, precise measurement of salt-to-water ratios using unrefined salts and avoiding iodized salt, maintaining optimal temperature control, ideally with a controlled incubator rather than just a counter, and monitoring the fermentation time to ensure the pH drops below 4.6. These measures are critical not only for safety but also for ensuring the deep proliferation and viability of beneficial live cultures that confer probiotic benefits. For commercial products, opting for unpasteurized varieties is key to retaining live probiotics, while dietary interventions are powerful tools for digestive health. It is imperative to be aware of potential interactions between certain foods, supplements, and medications, as well as specific contraindications for individuals with underlying medical conditions. Consulting a healthcare professional before making significant dietary or supplement changes is always recommended. Fiber, fluid intake. Fiber, particularly psyllium, can be unsafe if consumed without adequate fluids, posing a risk of choking or gastrointestinal tract blockage. Medication absorption. High fiber intake can decrease the absorption of certain medications, including carbamazepine, lithium, metformin, olanzapine, and digoxin. To minimize this interaction, it is generally advised to take fiber supplements at least 1 hour after, or 4 hours before other oral medications, or 30 to 60 minutes after for specific drugs like metformin. Nutrient absorption. Psyllium may reduce iron absorption and, over long periods, could affect the absorption of other nutrients, potentially necessitating vitamin or mineral SUPP, LEMENTATION. Contraindications. Fiber supplements, especially bulk-forming types, are contraindicated in individuals with gastrointestinal tract narrowing, obstruction, or conditions that predispose to obstruction, for example, spastic bowel. They should also be avoided by those with a history of colorectal adenoma, as psyllium might increase the risk of new growths. Probiotics and fermented foods. Antibiotics are designed to kill bacteria, and thus can prevent live probiotic products from working effectively. To mitigate this, it is generally recommended to take probiotics at least 2 to 3 hours before or after antibiotic doses. Interestingly, probiotics can also work in partnership with antibiotics by minimizing or preventing the changes to the gut microbiome caused by antibiotic treatment. Immunosuppression. For individuals with weakened or compromised immune systems, for example, due to HIV infection, chemotherapy, or organ transplant, there is a rare but serious concern that probiotics could cause blood infections. Such individuals should consult their healthcare provider before consuming probiotics or fermented foods. Damaged heart valves. An extremely rare but documented risk is that probiotic preparations can cause infections of the inner lining of the heart chambers and heart valves. Individuals with damaged heart valves should discontinue probiotic use before dental or surgical procedures. Histamine intolerance. Many fermented foods are naturally high in histamine. Individuals with histamine intolerance, often due to a deficiency in the DAO enzyme that breaks down histamine, may experience allergic-like reactions such as headaches and stomach upset after consuming these foods. Tyramine content. Pickled, cured, and fermented foods can contain tyramine, a naturally occurring compound. For patients taking monoamine oxidase inhibitors, MAO, is a class of antidepressants or certain medications for Parkinson's disease. Consuming tyramine-rich foods can lead to a dangerous increase in blood pressure, pregnancy, and breastfeeding, while generally considered safe for healthy individuals. Reliable information on the safety of specific probiotic strains, for example, L-gacery, bromelain, during pregnancy and breastfeeding may be limited. Unripe papaya in particular has been associated with potential harm to a developing fetus and is not recommended for pregnant or nursing individuals. Diabetes, phenylketonuria, PKU, some liquid, powder, or chewable probiotic products may contain added sugars or aspartame. Individuals with diabetes or PK, you should exercise caution and consult their healthcare provider regarding safe consumption. Enzyme-rich foods, supplements, bromelain, papain, blood clotting. Bromelain, found in pineapple, might slow blood clotting. Taking it concurrently with anticoagulant or antiplatelet drugs, medications that slow blood clotting, could increase the risk of bruising and bleeding. It is generally advised to stop bromelain at least 2 weeks before scheduled surgery. Antibiotic absorption. Bromelain may increase the absorption of certain antibiotics, particularly tetracyclines, potentially increasing their effects and side effects. Allergies. Individuals with allergies to pineapple, latex, ragweed, or other related plants may also be allergic to bromelain. Similarly, those with latex allergies may be allergic to papaya. Pregnancy. As mentioned, unripe papaya and papain are not recommended during pregnancy due to potential risks. Thyroid, blood, sugar conditions. Medicinal use of papaya may have safety concerns for individuals with thyroid conditions or those affecting blood sugar. Fermented forms of papaya may lower blood sugar to dangerous levels, especially for those on diabetes medications. The intricate tapestry of human digestive health is profoundly influenced by a complex interplay of dietary choices, lifestyle factors, and the dynamic ecosystem of the gut microbiome. This comprehensive review underscores that optimal digestive function is not merely the absence of discomfort, but a state of physiological harmony that underpins overall well-being. The evidence presented consistently highlights the foundational role of a nutrient-dense, whole food-based diet. Dietary fiber, in its soluble and insoluble forms, is indispensable for maintaining bowel regularity, shaping a diverse and robust gut microbiome, and producing vital short-chain fatty acids. Adequate hydration works synergistically with fiber, acting as the essential medium for efficient digestion and waste elimination. The deliberate inclusion of probiotic, rich, fermented foods, and prebiotic fibers actively cultivates a thriving microbial ecosystem, which in turn fortifies the intestinal barrier, modulates immune responses, and contributes to systemic health beyond the gut. Furthermore, essential vitamins and minerals provide critical micronutrient support for the myriad enzymatic processes and structural integrity of the digestive tract. Beyond these core components, the report emphasizes the importance of incorporating anti-inflammatory foods in omega-3 fatty acids, polyphenols, carotenoids, curcumin, and gingerols to actively mitigate gut inflammation, a key driver of many digestive disorders. Equally crucial is the conscious limitation or avoidance of dietary elements that actively compromise gut health, such as ultra-processed foods, excessive sugars, unhealthy fats, and common irritants like caffeine and alcohol. Crucially, the report reveals that digestive health extends beyond dietary composition to encompass lifestyle factors. Chronic stress and sleep deprivation emerge as significant disruptors, capable of inducing gut dysbiosis, increasing intestinal permeability, leaky gut, and fueling systemic inflammation through the intricate gut-brain axis. This highlights that addressing digestive issues requires a holistic paradigm, where stress management, adequate sleep, and mindful eating practices are as vital as specific food choices. The nuanced understanding of how individual dietary components interact with the unique microbial landscape of each person's gut underscores the imperative for personalized nutrition. The varying tolerability of different fiber types, the context-dependent effects of prebiotics in inflammatory conditions, and the potential for food-drug interactions all point to the necessity of individualized dietary strategies. Therefore, while this report provides a robust, evidence-based framework, professional guidance from registered dietitians and healthcare providers is often indispensable for tailoring interventions, especially for individuals managing complex digestive conditions. In conclusion, fostering optimal digestive health is an ongoing journey that demands a comprehensive and adaptive approach. By prioritizing diverse whole foods, embracing mindful eating habits, managing lifestyle stressors, and seeking personalized professional advice, individuals can significantly enhance their digestive resilience, promote a flourishing gut microbiome, and ultimately contribute to a more vibrant and healthy life.